Alright, so in this video, I'm going to solve the problem x minus 4 to the power of 4 is equal to x to the power of 4. So to solve this, I'm going to first start by rewriting this as x minus 4 squared to the power of 2 is equal to x to the power of 2 to the power of 2. And now I'm going to subtract x to the power of 2 to the power of 2 on both sides. So these two cancel out. And I get x minus 4 squared to the power of 2 minus x squared to the power of 2 is equal to 0. Now if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So now I get x minus 4 squared plus x squared times x minus 4 squared minus x squared is equal to 0. So x minus 4 squared is equal to x squared minus 8x plus 16. So I have this plus x squared is equal to 0. This is one equation. And I have x squared minus 8x plus 16 minus x squared is equal to 0. So for my left-hand side, I get 2x squared minus 8x plus 16 is equal to 0. And if I divide both sides by 2, I get x squared minus 4x plus 8 is equal to 0. For my right-hand side, these two cancel out, and I get negative 8x plus 16 is equal to 0. So I'm going to first solve for my right-hand side. So I'm going to add 8x on both sides, so I get 8x is equal to 16. Now if I divide both sides by 8, these two cancel out, and I get x is equal to 2. Now for my left-hand side, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So I get x is equal to negative 4 plus or minus the square root of negative 4 squared, which is 16, minus 4 times 1 times 8 all over 2 times 1. This is equal to 4 plus or minus the square root of 16 minus 32 over 2, which is equal to 4 plus or minus the square root of negative 16 over 2, which is equal to 4 plus or minus the square root of 16i over 2, which is equal to 4 plus or minus 4i over 2, which is equal to 2 plus or minus 2i. So these are my three solutions. Alright, so in this video, I'm going to solve the equation 2 to the power of x plus a to the power of x is equal to 10. So to solve this, I'm going to first start by rewriting 8 as 2 to the power of 3. So I get 2 to the power of 3 to the power of x is equal to 10. Now from here, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m. So I get 2 to the power of x plus 2 to the power of x to the power of 3 is equal to 10 because I switched the places of 3 and x. Now from here, I'm going to let 2 to the power of x equal to the variable y. So now I get y plus y to the power of 3 is equal to 10, and if I subtract 10 on both sides, I get y to the power of 3 plus y minus 10 is equal to 0. Now, what I need to do is first find one solution of y, and then once I have that solution, I can find the remaining solutions. So to do that and find that first solution, I'm just going to test values of y. So we're going to start with y equals 1. So when y equals 1, I have 1 to the power of 3 plus 1 minus 10 is equal to 0. Well, 1 to the power of 3 is 1, 1 plus 1 is 2, 2 minus 10 is negative 8, which does not equal 0. So this does not work. Now I'm going to try y equals 2. So when y equals 2, I get 2 to the power of 3 plus 2 minus 10 is equal to 0. Now 2 to the power of 3 is 8, so I have 8 plus 2 minus 10 8 plus 2 is 10, 10 minus 10 is 0. So this works, meaning y equals 2 is a solution. So what I'm going to do is divide y to the power of 3 plus y minus 10 by y minus 2, because y minus 2 equals 0, well, y equals 2 is the solution. So to do this, I'm going to use synthetic division. So I'm going to look at the coefficients of my numerator, and I have 1, which is the coefficient of y to the power of 3, 0, which is the coefficient of y squared. Remember, we're going order. 1, again, which is the coefficient of y, and negative 10. And just to let you guys know, the 0 is there because this is supposed to be y squared, because we're going in order. But because there is no y squared, we put a 0 in front of it. And this is all with 2. And if you guys are still confused by this, you should look up a video on synthetic division. So I'm going to first start by moving down my 1. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. 1 plus 4 is 5. And 2 times 5 is 10. Negative 10 plus 10 is 0. So I have a remainder of 0. And I'm going to use these as my coefficients. So I get y squared plus 2y plus 5. Meaning y squared plus 2y plus 5 times y minus 2 is equal to 0. So this is my equation, and I'm going to divide this into two equations. Y squared plus 2y plus 5 is equal to 0, and y minus 2 is equal to 0. So now for y minus 2 equals 0, I'm going to add 2 on both sides, so I get y is equal to 2. And for y squared plus 2y plus 5 equals 0, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So I get y equals negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times 1 times 5 all over 2 times 1. And this turns into negative 2 plus or minus the square root of 4 minus 20 over 2, which is equal to negative 2 plus or minus the square root of negative 16 over 2. And because we have the square root of a negative number, we cannot use the solution of y, meaning we can only use y equals 2 as a solution. And remember, we're solving for x, not y. And we let 2 to the power of x equal to y. So I have 2 to the power of x is equal to 2. And the only solution to this would be x equals 1, because 2 to the power of 1 is equal to itself. So x equals 1 is my solution to this equation. Now, if you haven't already, please make sure to subscribe, leave a like, and share this video to your friends or family. Thank you. Alright, so in this video, I'm going to solve the problem 2 to the power of 25 minus 1. So, to first start, I'm going to rewrite 2 to the power of 25 as 2 to the power of 24 plus 1. And then we have our minus 1 at the end. And the reason I'm doing this, and rewriting 25 as 24 plus 1, is so now I can use the property a to the power of m plus n is equal to a to the power of m times a to the power of n. So 2 to the power of 24 plus 1 is going to equal 2 to the power of 24 times 2 to the power of 1 minus 1. Now basically our goal throughout this video is to change our values to be as small as possible, so then at the end we can do whatever we need to do with them to get our final result. So 2 to the power of 24, how do we simplify this and make it even smaller? I can rewrite this as 2 to the power of 12 times 2. And another property of exponents is that if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 12 times 2 is going to equal 2 to the power of 12 to the power of 2. And I have this times 2 minus 1. So now I'm actually going to plug in the actual value of 2 to the power of 12, because 2 to the power of 12 is small enough where we know the exact value of it. So if you guys don't know what 2 to the power of 12 is, well, 2 to the power of 10, you should always remember this as 1024. So 2 to the power of 11 is going to be double of 1024, which is 2048. And 2 to the power of 12, which is the value we're looking for, is going to be double of 2048, which is 4096. So now I get 4096 squared times 2 minus 1. And now this is equal to, I'm going to simplify this, 4000 plus 96 squared times 2 minus 1. And the reason I'm doing this is because 4096 squared is really hard to calculate by itself. So if we change it to 4000 plus 96 squared, I can use the property a plus b squared is equal to a squared plus 2ab plus b squared. So in this case, a is 4000 and b is 96. So this turns into 4000 squared plus 2 times 4000 times 96 plus 96 squared. And I have all of this minus 1. Oh, sorry. All of this times 2 minus 1. Now, 4000 squared is equal to 16 million. 2 times 4000 is 8000, and 8000 times 96 is equal to 768,000. And now I have this plus 96 squared, which is equal to 9,216. And all of this I have times 2 minus 1. So now I'm going to add all these up. So if I add all of these up in the parentheses, I get 16,777,216. So now I have this times 2 minus 1. So if I multiply this by 2, I get 33,554,432. And I have this minus 1, which is equal to 33,554,431. So this is my answer to this problem.